What's up again, everybody? This is Mr. Harris bringing you some more math jewels. So, we're still continuing to talk about arithmetic and geometric sequences, and we're going to get a little more in depth with these two examples. So, let's get right into it. The first example says in an arithmetic sequence, the 13th term is 23 and the 15th term is 49. We want to know what is the common difference, and then we want to find the 14th term. So first thing we must do is, in order to find the common difference, they give us the 15th term. So I'm going to say the 15th term is equal to the 13th term plus 2 times the common difference, because the 13th and 15th term are 2 apart. So we're going to substitute 49 for the 15th term, 23 for the 13th term, and then plus 2 times d. So we want to solve for d by subtracting 23 from both sides. We'll get 26 is equal to 2 times d. Then we divide both of those by 2, which gives us 13 equal to d. So that tells us that the common difference is 13. Now, in order to figure out what the 14th term is, we're going to take the approach that finds the initial term first. So what I want to do is I want to take the 13th term, and it's equal to the first term plus 12 times 13. So I got that because up here with the n minus 1 is 13 minus 1, which gives us 12. So I have a1 plus 13 minus 1 times 13. Okay? So I know what the 13th term is. It's 23. Okay, so 23 is equal to a sub 1 plus 12 times 13 is 156. And so in order to get the initial term, we're going to subtract 156 on both sides. And when I subtract this, I'll get negative 133 equals a sub 1. So that tells me that the first term in this sequence is negative 133. Okay? Now, last but not least, in order to find the 14th term, I can simply just plug that into the formula. So I have a sub 14 is equal to a sub 1 plus n minus 1 times d. Okay? So the 14th term is going to be negative 133 plus 14 minus 1 times 13, okay, which gives us negative 133 plus 169, and when we do that, the 14th term, I'm sorry, that's an ugly 14, the 14th term is going to be 36, okay? So there's our 14th term in this sequence, 36. Moving right along to this example, we're going to be using a geometric sequence, and we're going to do something similar, but because it's geometric, it's slightly different. So let's move right along. Here it says in a geometric sequence, the third term is 2 and the fifth term is 8. What is the common ratio and what is the fourth term? So we're going to start off by saying we know that this is our formula. So we're going to say the fifth term is equal to the third term times r to the second power. So here the fifth term is 8, the third term is 2 times r to the second power. Okay? So I want to get rid of this 2 first. So I'm going to divide both sides by 2. We're trying to solve for r. So 4 is equal to r squared. And then if we take the square root of 4, we'll get 2 equal to r. We don't need to use the negative side because we're talking about a common ratio, but we'll look at that in a few. So we're going to say 2 is equal to r. Okay? Now I can tell that since the third term is 2 and the fifth term is 8, that is the reason why I can use positive 2 versus negative 2, because the sequence is growing. So in order to get now that we have the common ratio, we need to find the fourth term. And in order to do that, we now can say that a sub n is equal to a sub 1 times 2 to the n minus 1 power. So this is our explicit formula to find any term in this geometric sequence. So we're going to take the third term, and we're going to say a sub 1 times 2 to the 3 minus 1 power. Okay? Now let's do some substitution. So the third term in this case is 2. So 2 is equal to the first term times 2 to the second power. So we need to find this first term. So we're just going to simply say 2 is equal to a sub 1 times 4. 2 to the second power is equal to 4. And from there, if we divide both sides by 4, then we'll get 1/2 is equal to a sub 1, or the initial term. So now that we know the initial term, we know our common ratio, we can now figure out what the fourth term is. Now, let's go ahead and do that. So here, let's change that over to blue. So a sub 4 is equal to 1/2 times 2 to the 4 minus 1 power. Okay? So a sub 4 is going to equal to 1/2 times 2 to the third power, which, oh, I apologize for that mistake. That should be 1/2 times, this is where the 8 should go. So basically what we're figuring out is half of 8 is going to equal 4. So our fourth term in this geometric sequence is 4. Now, I must say, in these examples, there are different ways that you could work these problems out. Some people would just take the common ratio, and once they figure it out, they say, hey, the third term is 2. Well, I take that, multiply it by 2, and I'll get the fourth term. But I did it this particular way because it helps for the more difficult problems, the more tedious problems. So hopefully someone can use this around the world.